For decades, humanoid robots have existed solely in the realm of science fiction and multi-million-dollar labs. Robots capable of complex human tasks often cost upwards of $100,000. But now, Tesla is betting on a future where an advanced, walking, talking humanoid robot, the Optimus Gen 3, could cost less than a mid-range sedan, just $20,000. This isn't just a cost reduction. This is a complete revolution in robotics engineering. Welcome to Humanoid X Robotics. Today, we are deep diving into the single biggest secret behind the $20,000 Optimus, the engineering philosophy that makes mass production possible. The most significant cost differentiator lies in the vertical integration of hardware, starting with the physical form. Optimus is designed not for spectacular acrobatic feats like its rivals, but for industrial efficiency and human interaction. The key is the actuators, the electromechanical muscles. Traditional high-performance robots use custom, low-volume, high-precision hydraulic or pneumatic systems, which are prohibitively expensive and require complex maintenance. Tesla's secret number 1: custom, mass-produced actuators. Tesla engineers the actuators from the ground up, sharing core components like stators and rotors with its automotive motor production lines. This strategy drastically reduces the bill of materials, BOM, cost. Instead of paying a third-party supplier for an actuator that costs $5,000, Tesla can manufacture an equivalent, purpose-built unit for potentially $500 to $1,000 at gigascale volumes. Furthermore, the choice of electric power over hydraulics simplifies the robot's architecture. It eliminates pumps, heavy tubing, and fluid leaks, leading to a lighter, cleaner, and less complicated machine ideal for factory floors. If the hardware is the muscle, the brain is the true cost saver, representing secret number 2, scaled intelligence. Optimus does not use expensive 3D LiDAR for primary navigation. Instead, it relies almost entirely on the same vision-based AI architecture developed for Tesla's full self-driving FSD fleet. The core of this system is the FSD chip and the massive data sets collected from millions of Tesla vehicles globally. This data is the unmatched competitive advantage. Crucially, Tesla uses reinforcement learning, RL, in simulation at an unparalleled scale. The robot is allowed to fail millions of times in the virtual realm, perfecting its motor skills and task execution before the knowledge is transferred to the physical robot. This data-driven simulation-first approach bypasses the costly, slow, and labor-intensive process of training robots exclusively in the physical world, making the AI development cycle faster and drastically cheaper. Optimus Gen 3's abilities are not defined by peak performance, but by its generalized dexterity and human-like adaptability. While Boston Dynamics excels at dynamic locomotion, Optimus excels at manipulation in cluttered human spaces. Its hands, featuring 10 degrees of freedom and tactile sensors, allow for a pinching grip and the ability to handle a wide range of tools. This adaptability is the ultimate utility measure. Companies aren't buying a specialized machine. They are acquiring a reprogrammable labor asset that can pivot as business needs change, further justifying the $20,000 investment. At $20,000, Optimus is not just a robot. It is an economic force multiplier. Primary use case: the automation of human-centric spaces. The first deployment wave will target tasks designed for human hands: manufacturing, warehousing, and quality inspection in facilities like Tesla's gigafactories. The return on investment, ROI, is staggering. Assuming a robot lifespan of 5 years and minimal maintenance, the cost translates to roughly $4,000 per year. This is a fraction of the minimum wage in any industrialized nation. Secondary use case: the service and domestic sectors. The low cost unlocks the market for home assistance, elder care, and retail support, where current robotic solutions are either too expensive or too specialized. This price point transforms the humanoid robot from a futuristic dream into a practical, scalable labor replacement tool, fundamentally redefining productivity standards globally. Despite the breakthrough, The $20,000 price tag comes with inherent limitations that must be addressed. Robustness versus cost. Tesla's custom actuators, while cost-effective, may compromise the ultimate durability and sustained power output compared to military-grade systems. Can they handle years of continuous, heavy industrial stress, latency, and edge computing? Relying solely on camera input means the robot must process and react in milliseconds. Any significant latency in its perception-action loop could lead to errors, especially in fast-paced scenarios. The low cost accelerates the discussion on job displacement. Governments and corporations must proactively plan for the massive, rapid shift in labor dynamics this technology promises. The roadmap for Optimus is clear: scale, intelligence, and integration. Phase 1, 2025 to 2027. Internal deployment. The robot will first perfect its abilities in Tesla and SpaceX facilities, providing a closed-loop testing environment for rapid software iteration. Phase 2, 2027 to 2030. External industrial adoption. Once robustness is proven, Optimus will flood the industrial sector, establishing a global standard for general-purpose robotic labor. Phase 3, post-2030. The domestic market. The $20,000 price point will drop further as production approaches mass consumer electronics levels, ushering in the era of the personal robot companion. The true vision of Optimus is to become the android of robotics, a standardized, scalable platform that other companies can build specialized software and applications upon. This future is no longer decades away. The combination of cost-effective hardware and scaled AI has put the general-purpose humanoid robot on an exponential development curve. The secret to the $20,000 Optimus is not one single invention, but a comprehensive, vertically integrated system, mass-produced actuators, and vision-based AI scaling. This technological philosophy guarantees that the biggest barrier to robotics, cost, is officially collapsing. What aspect of the $20,000 robot concerns or excites you the most? Is it the impact on the job market or the potential for a personal assistant? Share your thoughts in the comments below. If this deep dive provided you with a new perspective on the future of AI, please hit the subscribe button and the notification bell to join the AI revolution. Thank you for spending your valuable time with us. See you in the next analysis.